Today we're on page 3 of our Chapter 14 notes packet, and we'll be covering pages 3, 4, and 5 with today's video. You're going to be introduced to two more formulas, and again, these formulas are given to you. They're on the reference sheet. So the first one is for the area of a triangle. When the measures of two sides and the included angle of a triangle are known, the area of the triangle, which is denoted by a uppercase K, can be found using the formula K equals 1/2 AB sine of C. In other words, we have a triangle ABC, and the area can be found by taking 1/2 the product of the two included sides, A and B, and the sine of the included angle, which would be C. So we need the lengths of the two sides that make up the included angle. Again, this formula is given to you, and it's on the reference sheet. It's actually the first formula on the reference sheet. Area of a triangle, K equals 1/2 AB sine of angle C. You have learned that the area of a triangle, you're more familiar with the formula 1/2 base times height, but sometimes the height is not known. If you know the lengths of two sides and the included angle, then, as mentioned before, the area is going to equal 1/2 the product of the two sides times the sine of the included angle. In the first example, we want to find the area of triangle ABC to the nearest tenth of a square meter. Okay, well, what do we have? We have the measure of angle C, and we have the lengths of the two sides that make up angle C. So the area of the triangle, I'm going to use capital A, area of the triangle, is going to equal 1/2 the product of the two sides and the sine of the included angle. Right. Again, instead of using the actual formula in the form of letters, I just like to use it in the form of words. It's going to be 1/2 the product of the two sides times the sine of the included angle. So now we go to our calculator, make sure we're in degree mode, and just be easier to key in 0.5 instead of 1/2. 0.5 times 24 times 30 times the sine of 40. 231.4035395, and we want to the nearest tenth, so that would be 231.4. The next example, an isosceles triangle has legs of lengths 12 inches and a base angles that measure 32 degrees each. Draw a diagram. Isosceles triangle, the lengths of the legs are 12, the base angles are 32 degrees each. We want to find the area of the triangle to the nearest tenth of a square inch. Okay, well, in order to find the area, it's going to be 1/2 the product of the two sides times the sine of the included angle. Well, we don't have this included angle, right? The included angle is the angle that is formed by the two sides that we have. So if these are our two sides, okay, this is the included angle. But we can easily find that. We know that the three angles of any triangle add up to 180. So if we add our two base angles, 32 plus 32 is 64, and then subtract that from 180 to get what we call the vertex angle of our isosceles triangle. which would be 116 degrees. Okay, so now we know the angle measure. Now we go to our formula for area of a triangle, which is going to be 1/2 the product of the two sides times the sine of the included angle. So times the sine of 116 degrees. And back to the calculator. To nearest tenth, 64.7. We're going on to page 4. Looking at example 4. The adjacent sides of a parallelogram ABCD measure 12 and 15. Okay, we've got a parallelogram diagram drawn for us, so let me put down the shorter side's 12, longer side 15. The measure of one angle of ABCD is 135 degrees. All right. Well, that would be our obtuse angle, 135. Opposite sides are congruent in a parallelogram, and opposite angles are congruent in a parallelogram. So, don't know if we'll need it, but what would our other two angles measures be? Well, consecutive angles of a parallelogram are supplementary, remember? So 180 minus 135 is 45. All right, let me continue. The measure of one angle of parallelogram ABCD is 135 degrees. We want to find the exact value of the area of ABCD. Okay, well, we'll split this into two triangles. All right, so let me draw the shorter diagonal. All right, so now we have two triangles. And we know the exact value of the sine of 45 degrees. All right. So let's take our area formula, and this is the area of one triangle. The area of the triangle is going to be 1/2 the product of the two sides, the 12 and the 15, times the sine of the included angle. So that's equal to 1/2 12 times 15 times the sine of 45 degrees. So half of 12 is 6 times 15. $90. And the sine of 45 degrees? Square root of 2 over 2. 2 goes into 90 45 times, so this would be 45 square root of 2. But that's just one triangle, and our parallelogram is made up of two triangles. So let's simply double this. So the area of the parallelogram, let me go back and note that that was a triangle. So now this is our parallelogram, would be 2 times 45 square root of 2, which results in 90 square root of 2. So there's our exact value of the area of the parallelogram. Skipping example 5 for now, and going on to the next formula, which is law of sines. And law of sines is also on the reference sheet here. In any triangle, the ratio between the sine of an angle and the length of the opposite side is a constant. The law of sines says that the length of the side opposite angle A, the ratio of the length of the side opposite to the sine of the angle, is going to equal the ratio of the length of the side opposite angle B to the sine of angle B, which would also be equal to the ratio of the length of the side opposite angle C over the sine of angle C. Again, once again, this formula is on the reference sheet. When applying law of sines, we set up a proportion involving two angles of a triangle and the sides opposite the angles. And the best way to show you this is to go through examples. In the first example, we have in triangle ABC, BC is 16. That's already noted for us on the diagram. The measure of angle A is 80. The measure of angle B is 32. And they also gave us the measure of angle C is 68. We want to find AC to the nearest tenth. Then find the area of the triangle. AC, okay, would be denoted by lowercase b because it's opposite angle B. So look at what we have. We're trying to find this, all right? So we're using this side and the angle opposite it, and then the other side that we know, the 16, and the angle opposite it. So we set up a proportion saying that the ratio of the side opposite angle B, lowercase b, to the sine of angle B, so B over sine of 32 degrees, is going to equal 16 over sine 180. I think I said 180. It's just 80. Okay, so here we have our proportion. Cross products and a proportion are equal, so we cross multiply, and we have B times sine 80 equals 16 times sine 32. And please have the equation solved for the variable before you go to your calculator. B times sine 80, what undoes multiplication is division, so we would divide both sides by sine 80. And we have B equals 16 times sine 32 divided by sine 80. Now let's go to the calculator. Alpha y equals 16 sine 32 over sine 80. We want to round to the nearest tenth, so this would be, I put in 12 for some reason. Let me do that again. That's 16 sine 32 over sine 80. Okay, so rounding to the nearest tenth, this is better now. That's 8.6. So B equals 8.6, or AC equals 8.6. Second part, we want to find the area of the triangle, right? Well, now that we know that this is 8.6, okay, we'll use the sides that we have, the two sides, and now the included angle would be this angle of 68 degrees. So the area of the triangle is going to equal 1/2 the product of those two sides, 8.6, times 16 times the sine of 68. Calculator. .5 times 8.6 times 16 times sine 68. We'll also round this to the nearest tenth, so 63.8. Three more examples on page 5 to continue with. The next exercise we have in triangle DEF. I'll stop right there, draw a diagram. The measure of angle D is 47 degrees. The measure of angle E is 84 degrees. And lowercase d is 17.3. So the side opposite angle D is 17.3. we want to find e, lowercase e, all right, to the nearest tenth. Okay, well, what do we have here? We have our two sides, and we have the angles opposite them. So this is using law of sines. So we set up our proportion. The length of the side opposite angle E, lowercase e, is to the sine of 84 as the side 17.3 is to the sine of the angle 47 degrees. Here's our proportion. Cross multiply, e times sine 47 equals 17.3 times sine 84. We want e by itself, so we divide by sine 47. So e equals 17.3 sine 84 divided by sine 47. Go to the calculator, alpha y equals, I want 17.3 sine 84 divided by sine 47. To the nearest tenth, 23.5. Does it seem reasonable? 23.5? Yeah, that's opposite our 84-degree angle, so it certainly should be larger than the length of the side opposite the 47-degree angle. Next, in triangle PQR, stop there, draw a triangle. The measure of angle P is 125 degrees. All right, well, that's an obtuse angle. Not that my triangle is representative of that, but again, we'll be working with the numbers, not with what it looks like. The measure of angle Q is 14 degrees. Lowercase p is 122, so the side opposite angle P is 122. We want to find lowercase r to the nearest integer. Okay, so we need to find the length of the side opposite angle r. And we have two sides that are represented. All right, so this is using law of sines. We need to know what the measure of angle r is, but we can easily get that. We take the 125 plus the 14 and subtract that from 180. 180 minus 139 is 41. So angle r is 41 degrees. Now, set up a proportion using the law of sines. R over sine 41 equals 122 over sine 125. Cross multiply. R times sine 125 equals 122 times sine 41. And divide by sine 125. So r equals 122 sine 41 divided by sine 125. Go to the calculator. To the nearest integer, all right, 97.7. All right, the nearest integer, this would round up to 98. And the last example, in triangle DEF, again, stop, draw a diagram. The measure of angle D is 81 degrees. Lowercase d is 10, so the side opposite angle D is 10. And lowercase e is 5, so the side opposite angle E is 5. We want to find the measure of angle E. Okay, well, we have our two sides, and in this case we're looking to find the measure of the angle opposite one of our two sides. So we're using law of sines. Our side of 5 over sine of e would equal our side of 10 over sine of 81. Cross multiply. 10 times sine of e is equal to 5 times sine 81. We need to get e by itself, so let's first undo the multiplication by 10 and divide both sides by 10. So the sine of e is equal to this fraction. So how do we find e, the actual angle measure, right? How do we find angle? Angle e is going to equal the sine inverse of that fraction. Okay, so angle e equals the sine inverse of 5 sine 81 divided by 10. So let's go to the calculator. So second sine alpha y equals 5 sine 81 divided by 10. To the nearest minute. Okay, this is decimal degrees. Recall, what do we need to do now? Second apps, number 4. Degrees, minutes, seconds, so 29 degrees, 35 minutes, 36.825 seconds. Remember, if your seconds are 30 or more, it will round up to the next minute. So this will be 29 degrees, 36 minutes. So angle E would have a measure of 29 degrees, 36 minutes. And this concludes our video for today. Thank you.